1, 2, 3. 1, 2, 3. Work. Good enough. Waiting for your command.
I don't have any commands. Hello, everybody. Oh, that was bright. This is Serge. He's going to talk. Afterwards, we're going to go for food and drink, either up here or at minimums, either or, depending on what y'all want. And I don't really have any announcements. I'm tired. So
that's a good announcement.
Announcements. I'll think of something afterwards. So anyway, enjoy the talk.
Awesome. Just quick info. It's about 40-minute talk, so you know how much time you have to tolerate me. And then about 20 minutes, up to 20 minutes for Q&A, and as Adrian said, we can go to the bar and do more geek out. OK, ready to go? Awesome. So about several years ago, I found this interesting research that tells that developers spent about 70% on not writing the code. Yeah, I see the laughs. And this is crazy, actually, because what do? We spend about 70% of time on maintenance, like debugging, troubleshooting, bug fixing. And now the complexity of building the modern cloud applications, I think it gets even worse. Maybe we spend only 5% of the time on writing the actual business logic, the essential complexity. What do? I think this is insane. At the same time, we have really good news. Apparently, the public cloud market goes really high. And today, we're about a 70 billion market approximately. And we're going to 1 trillion. And this includes all different kind of offerings like SaaS, PaaS, IaaS, and other things. And this is actually good news for developers because we have more jobs. At the same time, we have to do more work, build even more cloud applications. We either need to do more developers or find a way how to do things that we do today in a much easier way. But I want to focus on the microservice trend. There are a lot of things that you can do in the cloud. And the trend started about 6 years ago when it became, I would say, available to the public. And this is a chart from the Google Trends for the keyword microservices. And you can see that it reached its peak, and you may assume that's going to go down. It doesn't really matter if it goes down or up. I would say within those years, the concept itself became mature. Even though we don't have proper frameworks or tools that allows us to do them in a much, much easier fashion, but the concept itself is mature. And with the modern cloud providers, you can create microservices in different languages for Google Cloud Provider, AWS, and Azure. And you can use languages like Go, Java, C#, and perhaps assembler. Why did we see an explosion of services written in assembler? This is silly, right? They said any language. OK, so I want to go back a little bit in history and start with assembler. Assembler was an awesome invention back at that time that solved a really cool problem. You can program any CPU with the similar instructions, and it was great. And there's a few languages in between, and we invented C# and C++, and those kind of languages introduced new abstractions, like functions and data structures. It sounds silly today, but back then it was not available in assembler. And one side, you see how it's easy to create a program with C, C++. On the other side, you have opponents saying, hey, you know what? I don't trust the compiler. It doesn't do the job as good as I can do myself by writing program in assembler. My program is going to be faster. And later on, we found that 99% of problems can be easily solved in C and C++. And maybe 1% requires some intervention and writing things in assembler. Later on, we have Java and the first SOA, service-oriented architecture. And we have a similar debate. Java introduces garbage collection and solves tons of problems of manual memory management, On the other side, we have opponents saying, you know what, I don't trust that memory management piece. I can do memory management in a much more efficient way. At the same time, today we know that it's much easier to do things in Java, and only certain applications require more low-level programming. Then C# tags along, and with the first cloud concepts. And today we have microservices. Look how smart we are. We'll look back to all this history and think, why did we do this? Why did we start with such low level things when we can do things in a much more easier way that we have today? The answer to this question is very simple. Back then, we just didn't know what kind of challenges we will have in the future, and we were solving challenges at that point in time. So maybe like in 5-10 years, we'll be holding that new key, new secret, and we'll look back in microservices and say, you know what, that was silly. Why do we even do microservices? So at some point of time, microservices become so ubiquitous, so cheap, it will be zero cost to build them compared to what we have today. But we're not there yet. But one point on this slide is that we have some concepts, repetitive actions that we do over and over again, and at some point of time, it becomes a part of the language. So today's challenges of building service-oriented applications, there are actually lots of them. And this is a terrible slide. It has 12 bullet points. I'm sorry.
No pictures.
And no pictures, yes. And no jokes. And if you think about building an actual production application, you have to tackle all of them. Yeah, there are some frameworks that can help you with some of them. You have to find a way how to glue things together, but you still have to do all of the things. And a typical cloud application can be visualized as 4 layers. At the very top, you have your application code, which represents the essential complexity, the business rules. And then you have, at the same layer, you have incidental complexity, which effectively is a glue that wires up different frameworks, libraries, and components that is written in a certain programming language. And there is nothing outstanding here that's like a typical application. Doesn't matter if written for the cloud or a desktop application. But there are some differences between building a single process application and a cloud application. And what if we take this bottom layer, the language, and move it a little bit up, just underneath the application code? So the application code can represent only the business rules, your essential complexity. We introduce new paradigms in the language itself that are cloud native, which can hide all the complexity of binding the frameworks, libraries, and components. And here's a good example how the language evolved, AsyncAwait. AsyncAwait was introduced back in 2012 with C#. And this is a random example from the internet. On the right side, it shows an example of the code written with AsyncAwait. On the left side, we have a compiler-generated code for AsyncAwait. And the difference is 10 times in amount of code. And the big question is, what does it do? What does code on the left side do while it achieves exactly the same behavior of the code on the right side? And it's interesting that the code written in exactly the same language. It doesn't change any business behavior. The thing is, on the right side, we have new paradigms that introduces the intent, what you want to do. And the left side, you have implementation details, how it's done. So the details can change over time, but your intent does not. And what we do today with the cloud applications, we usually reference some tutorials, some reference architecture, and it can be a little bit overwhelming and frustrating. You go to one tutorial, it tells you do this. It turns out to be too simple for your production purpose. On the other hand, other extreme, you have a blown up production-ready reference architecture. And it's really hard to distill those 1 or 2 pieces that you want to put inside your application. There's nothing wrong with doing frameworks. But the idea that delivering a new concept to your application is harder than delivering new binary, new executable to your application. Personally, I don't know any single person that would go back 6 months later after copying reference architecture, finding those changes and applying to your production. This almost never happens. So while building the cloud applications today, today's norms are we design API first, at least from my experience. We build controllers, usually HTTP controllers. Then we create manually or usually generate service clients, so we can call the service externally. And then you start thinking that this is not enough. You want to have asynchronous APIs. You start thinking about how you want to design your asynchronous APIs, what the persistent layer you should use. And then you realize that your compute can fail with asynchronous APIs. So you start thinking, how do you want to guarantee execution of asynchronous API? You start resorting to the message passing mechanism. And then when you want to combine those messages together to create a workflow, you start thinking about how do you persist your workflow, how do you save the state, so you can easily create this kind of workflow. And beyond that, you can do reactive programming with events, and you have to write a lot of event handlers and message handlers and a lot of error handling code. And the one thing that is rarely talked about is there are some problems of distributed computing, like exactly once delivery of a message and the ordering of the message. And it's not that easy to solve. There are some solutions. But when you see how it's solved, your code just blows up. And usually what you see, you start designing from the very top, from the very first step, like shown number 1, and then you push out the rest for the later, because it's hard. And the funny thing, it doesn't even change any business rules. All these are non-functional requirements. This is incidental complexity. So if we step back a little bit from the cloud applications and go to the simple world of a single process, let's say a command line application, you can represent services as classes. And this code is written in C#. In this example, we have I hope you can read it. Back rows, can you read it? OK, awesome. So in this example, we have a user service. And it has two methods, register user and suspend. And there is another service, the actual implementation of service, fraud detection. And let's say there are some logic runs and triggers a signal that a user has been potentially committed a fraud. So we want to suspend the user. In this simple desktop application, we just call a method on an interface, on abstraction of different service, saying, hey, I want to suspend the user. Now imagine doing the same in a cloud application. Now we go back to all of these problems. What kind of communication mechanism do you want to use? Is it HTTP, RPC? Is it message passing? How are we going to host this? How the service is actually going to communicate in one ecosystem? And actually, how can you guarantee the execution of another method on different service? There's a lot of problems. But actually, we're not that far from having the idea, the communication between services inside the code itself. For example, if you look at the GraphQL or gRPC, the protofile, for example, has a service keyword, because the modern world revolves around services. It would be awesome if the language like C#, Java, and others have these special keywords that brings us the visibility that the call is going to be made over the network, regardless of the communication mechanism. Then events. Events allows you to do reactive programming, and very helpful for microservice world, where you can decouple services from each other. Instead of one service doing the orchestration of other services, you can shift the business logic and shift the decision making to the other one. And again, this code written in C#. We have a user service again. it allows us to add a user, and when the user is added, we invoke an event. So for those who are not familiar with C#, C# has an awesome keyword, event. Event implements the observer pattern, so you can subscribe and invoke all the subscribers. So the .invoke in the beginning of this code allows us to invoke event. And the service at the bottom, which is called reward service, with the syntax plus equal, subscribes to this event and can perform any logic in the methods on user added. So once again, we're not really far from these concepts where a service from high level subscribes to events to a different service. And imagine how you would do this in a cloud application. Do you want to use HTTP, HTTP, how do you call them? The, sorry, I forgot. You know, like when you register HTTP callback. Webhooks. Webhooks, here we go, thanks. Webhooks, do you want to use webhooks? Do you want to use Kafka topics or like streams in this case? And there's a lot of incidental complexity to put on top of this. It doesn't change any logic again. The workflows. The workflow is an interesting word. To me, it means a series of steps, a blueprint of those steps. And this example shows, once again, a single process application that performs a series of steps. The first one is here we try to make an order. So the first step, we are trying to make, credit a buyer first. Then we try to reserve an item in a warehouse. And let's say the warehouse is out of this item, particular item that the buyer is trying to purchase. So in the exception handler, we try to refund the user. It's a very simple series of steps. Now think about how would you this implement with the modern frameworks if it's just distributed across multiple services. Do you use choreography? Do you use orchestration? Once again, how do you implement events? How do you implement message passing? There's so many things that you have to solve. And besides that, you have to split down these methods into small, tiny message or event handlers so that you cannot see longer the workflow. It's not longer like a concise forms where you see a series of steps. You have to travel across all the code to see what's going on. So once again, we're not really far from the concept of the workflows. We just don't have a visibility in the language, how to say this method's actually workflow. Some items has to be persisted, and we have some calls over the network to make it run in a reliable way. And then we have consistency. Usually we talk about consistency as a separate thing on the communication mechanism, like a event bus or message stream. And then we have consistency in a database. But once you try to put them together, your consistency disappears. And what I mean by that is it's really hard to achieve an atomic operation to make sure that when you commit something to the database, your message or event that you sent is committed in the same transaction. There are some patterns. I highly recommend an article called Life Beyond Distributed Transactions, written by Pat Helland. It explains how it can be done. But if you look at the implementation, again, your code just blows up. It's really hard to understand why you have to do this in the first place. And in this example, this is, again, the user service. We try to enable a user. And there is a repository that backed by a database. And first thing you want to check if the user is already enabled. If not, we want to enable, save to the database, and emit an event. If it's a mission-critical function, probably it's backed by a message. And whenever the failure happens, you want to retry this message. And that means you can deliver a message more than once and maybe override some changes in the database or emit an event twice. So you have to think about the concurrency check, if it's a single transaction or is optimistic concurrency check. Even though if you save the record to the database, what can happen next, You can have network failure, so you fail to meet your event. But even if you emit your event, it doesn't guarantee that you commit the message that is being processed. It becomes really ugly and frustrating. Well, here's another example of architecture of a product which does none of it. After 2 months of development, there were 8 services, about 50 minutes and 20 events, and 0 non-functional code. That means there is no APIs, no controllers, no message handlers, no need for any workflow framework, none of that. And the reason why you see those boxes, they just represent the functional aspect of the application. The names don't really matter. The idea is they're separate services. And if we look at the technical side of it, the idea is that you can take any of the service and communication between them and switch them on the fly whenever you want without changing any line of code. The idea is that you cannot know the design requirements most of the time up front. You want to do some measurements to figure out if you want to have better latency, better price, better scalability, and select it later. And this actually goes just beyond the idea of a technology. The whole idea of microservices is intersection with the organizational structure. We talk about the Conway Law. And most of the projects start with one team. And when your project succeeds, you have more people on the team, your organization grows, and you have more teams, more people and more teams. And the typical approach, you have more like a monolith kind of application. You have to have a painful breakdown. You have to send out these new APIs. But in this case, the cost of creating a service is nearly 0. So you can easily create a new service and plug it in the system and easily divide without changing any contract. It's all exactly the same. And the question is, does it even worth to think about going this direction where the language can represent the cloud-native abstractions? So the internal research, it's not 5 sigma yet, showed that you can design, develop, and evolve the business logic, the essential complexity, about 30 times faster than you would do today. And the secret is you no longer mix those that essential complexity and incidental complexity together. So it's much easier to read the code. It's much easier to understand what it does, and much easier to make a change. And beside that, you have almost nearly 0 effort to tackle most of the common non-functional aspects, like creating service and plug it into your system. It's almost for free. And last but not least, it feels good and empowering because you're no longer funneled into these problems, how to stand up Kubernetes or how do you put something in Docker. That just goes on the second place. Now we have more time and resources to think about something that is very unique to application, that is very unique to your business. And you have more time to spend on the new challenges. And maybe in the future we have something in common that we don't have today. But that's for a talk for another time. So the big question is how. The project is called DaSync. The name derives from distributed asynchronous functions. Even though it doesn't have a language extensions yet, which are planned for C# for now, the generic engine is available on GitHub right now. And the cloud platform that allows to run it only in the private with the first adopters, and it's going to be available very soon for the public. I spent about 3 years of research and development to make it real. And the reason is I believe that in the future for developers is bright, that every developer will have an ability to create a microservice without using any framework through the language abstractions. Thank you. OK, so just before we start Q&A, the demo is going to be next time, not today. This is not an imaginary product. It actually exists. But today you can go to the website, dasync.io, and the very bottom of the page, you can subscribe for notification for the first experience. And my name, once again, Serge Semenov. You can find me on Medium, LinkedIn, or Twitter if you want to geek out. Also, I have business cards over there by the projector if you want to take one. OK, Q&A is open.
What do you see as the benefits of DaSync versus some relatively similar ideas with like dark lane? Have you looked at that?
OK, yeah. So the question is, what do you see the benefits of DaSync compared to dark lang? Have I thought about this? And have I seen it? Yes, I've seen the demo of dark lang just came out on YouTube yesterday. And the first, my impression, personal expression, from what I saw, it's very HT-based, similar to Ballerina. I can be wrong. Also, dark lang is hard to tell which runtime it uses. So it's really hard to say how it can integrate into existing ecosystem. With DaSync, the project focuses on existing languages. So you can reuse existing ecosystem and just do like small adjustments to make it much easier to work with.
Can you go back to the consistency slide?
OK, can I go back to the consistency slide? Here we go.
So I didn't quite get the key takeaway from this. You're saying if the event emission fails, then we won't actually save to the DB, or if the thing that's subscribed to that event fails, then we won't save to the DB, or if we have to replay the message from an idempotency standpoint, then because we have the concurrency check in there, like
OK, there's
it was a little too over my head.
OK, just to repeat, there's a lot of words said, but I'll summarize like what the point of the slide. Once again, the point of the slide to show there can be a lot of complexity to even execute one single method, because you can easily go to inconsistent state. It's really hard to guarantee one atomic transaction of, let's say, saving something to the database, putting something, let's say, into the event stream or message queue, and actually deleting the message from the queue which are currently being processed. It's really hard to guarantee this one atomic transaction. And the idea is, what if the language had some new abstraction that we don't have yet that can at least show us that, imply that we want to achieve this?
Oh, so you're saying if either of those I/O calls fail, it will all be rolled back?
Yeah, something like that, yeah.
Okay, so you're not actually waiting for the event, because if you were to run this in a single application,
Yeah.
whatever was being invoked on the user enable event through an exception,
Yeah.
then the database record would not be written, right?
Yes.
So does that also work with DaSync?
Yes. So there's a plugin, I would say, to DaSync which works with the SQL DB right now, which allows to execute the whole method as a single transaction, guarantee the atomic execution of all events or commands, whatever you have in the method. Yes?
So staying on this slide, how do you do that? One way I can imagine you do that is that you write to the DB, and then in the same database transaction,
Right.
you're writing into some sort of message queue, and then you have like a subscriber on top of that message queue, and that you can do, if you're lucky, you could do exactly once the DB off of that.
Yeah.
How do you do it?
So the question is, how is it done? So there's multiple ways to do this, and currently there is a pattern that is used, which is called, I think it's called Outbox Command Outbox pattern. So essentially, the idea is that you commit with your entities, you commit certain things into the database in the same transaction, which tells you if the message, and like it can be like a message at the message data, or you can just flag that message has been processed, for example. Yeah, and the message data duplication is another hard topic. You can use a lot of things to do that.
If you have the outbox, you have a lot of freedom with respect to the semantics of how you notify. You know, you
Mhm.
can do exactly once, you could do at least once.
Yes. Yeah, but the idea here is you have like a simple logic which works, let's say, with the database. Once you commit the entities in something into database in one transaction, you can almost guarantee the exactly one semantic. And also there is a built-in concurrency check that allows you to check if the state of an entity has been changed since you read it, and at the time when you want to write it back to the database, so it automatically retries. You don't have to write that logic.
So what do the users, like, what price do they pay for this? Do they have to use your entities so you can control them?
The question is, what price do they have to pay to use it?
Yeah.
In terms of,
In terms of, like, you need to have some control, right? Because you want to intercept the database right.
mhm.
How do you do that?
Okay, so there's a lot of technical implementation details. We can definitely chat a little bit after the Q&A, because we can definitely go very, very deep into hard problems of distributed computing.
I think sort of what his question was driving at is like how much of it is like convention based
Mhm.
versus things that like a user will directly have to, like for example, like if I want to inherit from a class, I need to directly inherit it.
Mhm.
Like so how much of it is like convention based versus user actually having to like tie into your system?
Okay, so the question is how much it is convention based versus user have to.
Like I don't know, are there hooks that they
Yeah.
have to tie into?
Mhm.
Like I don't really get where the user code ends and then DaSync picks
Yeah.
up the work.
Okay, yeah. So I would say the concept of DaSync is to hide those things because they are irrelevant. Even though you want to have control of doing those things, the message is you shouldn't. Because the idea is once you, to my mind, today we do assembler. We just need new abstraction that hide all the things of assembler. Yes, you can find the implementation details. Yes, you can probably build in some hooks and tweak something a little bit. But the idea is, in most cases, you don't really need that, if it makes sense.
So like, is this an example of
Yeah.
code that would actually run with DaSync?
Yes.
Like for instance, how does the just change in any type of state imply a save to a database? Like what if I just want to mutate some state,
Mm-hmm.
but I don't know. Like is user an object that is something from DaSync that's
Oh.
tracking like there are changes on that object, so I should save it?
In this example, it uses, it's not shown, but it uses entity, implies that you use entity framework. So the user is the actual your model that you build, and then you use entity framework on top of that to map it to the actual database records, right? Yeah. And entity framework has all this cool stuff which can track the changes and save it to the database. Another question?
On that, I'm assuming if you're using Outbox processor for SQL, that would be an additional table that you would create, maybe in a separate schema. Is that kind of like the idea behind it? Like keep it kind of away from your code, but like it exists, but don't worry about it, kind of idea?
Yeah. So the question is, if it uses a command outbox pattern, does it create a new database table, and that you don't have to worry about? And yes, this is how it does. It creates an extra table which has some entities that it commits in the same transaction. Another question?
Sure. Can you help me to understand? So DaSync is a way to express functional requirements in the code, right?
Yes.
Abstracted from non-functional concepts. So it means you can run on multiple compute and storage platform agnostic, right? You can run on GCP, AWS, or Azure, or you target a specific
Mm-hmm.
platform like Azure. Do you target a specific platform, or is it agnostic?
Okay. So the question is, does DaSync work with other platforms? Is it agnostic from different compute and other mechanisms? In general, the idea, yes, the first thing comes with the language abstraction. Then I have a general execution engine, which is available for C# only. But you know that you can run .NET in AWS and GCP and Azure today. So technically, yes, you can run it anywhere, on your local machine, in the cloud.
So, like for example, I will give you one example. I don't know if you thought about that, but if I want to use specific provider of the streams, AWS has Kinesis and GCP has something else which I'm not aware of. Do you build abstractions over it, and you have some drivers for that, or how does it look like?
Okay, so the question is, to summarize, how does it hook up, let's say, to a provider-specific technology? The idea is there will be a lot of things that are available out of the box for different cloud providers, but definitely you can build your own if you want to. And the idea is, even if you build one and plug it into the system, you still don't have to change any of the business code, business rules code. Yeah, and from the demos that is going to be next time, you'll see how you can manage all the things on the fly using the most common, let's say, event streams and message buses available in the certain providers. Another question?
So sorry if this is a little bit of a repeat.
Yeah.
I'm still trying to get my head around the user-enabled.
No more consistency questions.
If that event handler, let's say I'm going to subscribe to that event. If I throw an exception, is DAsync going to retry my event handler method for me, or is it going to block the enable user method?
Okay, so actually this is a good question. It's not related exactly to consistency. It's a question about error handling. And the idea is, today we have to write a lot of these error handlers, try to figure out what we have to do if an error occurs on the network, let's say, or infrastructural side. The idea of DaSync is to hide those things by default, so they never ever pop up to your user code, ever. So you have to focus. You can focus only on your business logic. You don't have this ugly exception catches and trying to figure out what you want to do with that. It makes sense.
But I still want to know if an exception occurred. Right?
Yes. Absolutely. If you want to know, there's definitely in the engine itself, there's a lot of kind of things that you can log and publish some telemetry somewhere, and you can observe everything. Another question.
How about configuring exponential backup or retries or timeouts?
Yeah. So how about configuring different infrastructural things like backups, retries, maybe circuit breaker, whatever you want? Definitely. So think about this. Take any framework. How many options it has? Gazillion, right? So the idea is, yes, you have all the options. You have all the control. The thing is, yes, you can configure them, and it definitely is going to be available. It makes sense.
Are you thinking about that as a configuration file or configuration system, or would that be code that I write?
Is it going to be a configuration file, so the code that you write? I would say that at this point, with the out-of-the-box solutions, it's going to definitely be a configuration, so you don't have to worry about writing any code. If you want to write something by yourself, it's going to be code, apparently. Another question.
So what happens when something does go wrong and I need to debug it, and it's not in my code?
So what happens when something goes wrong? Well, apparently you contact developers, ask them to fix the problem.
If none of my code is the one that's breaking, how do I get any insight into that or know what's breaking where? I don't know.
Like what logging or whatever you have?
We could look at that. He's going to have to put state in there.
Yeah, so
Messages got delivered, that's outbox pattern.
I'm not going to fix it, but I need to figure out what is the issue so I can at least triage it and communicate to people what's going on.
That's a good question. How do you actually debug this if something goes out of hand and this is not your code? So I assume you use Visual Studio and NuGet package, NuGet.org. It has awesome feature. So this is there's a lot of things delivered as NuGet packages, and it has awesome feature. You can actually deploy symbols and with the source code, so you can actually debug, step into the code, and see what happens there if you need this.
I mean, but then I would need to have like some type of understanding of like the system behind the veil.
Yes, that's correct. As with any technology, I would say. Personally, I had to debug how JSON serializes, Newton self-JSON serializes things for certain reasons.
Yeah. So follow up to that question, if I wanted to see the magic sauce kind of messages flowing through my services, is there any way, like I could see that, so I think, I don't know, maybe like hook into, what's the thing that Uber built, the Gopher? Or Jaeger, yeah, or any kind of like traceability where I can trace kind of message executions or get like some kind of distributed stack trace or anything like that, right? Can I, if my event handler again throws an exception, and I look at my stack trace, could I see that I'm being called from, service A and I blew up over in service B, or?
Yeah. So the question is the kind of troubleshooting, the observability, and I would say the way how you want to trace what service calls another service, and like this question related to distributed tracing. Yes, this is built into the platform, and you definitely can connect multiple providers for collecting this telemetry. And I'll give you a hint. There'll be integration with the source control. So you can see what calls were what from exact line of code.
Can I run it in production?
Say again?
Can I run it in production?
You actually already do. Just for the audience, those 3 people are actually one of the first adopters of the technology. Okay, so we don't have. Oh, okay.
Yes.
Another question.
I've heard a lot about Ballerina.
Yes.
I guess and it seems similar, but this is more C# focused. What's the big difference? Do you want to join like APIs?
Okay. So the question is, how is it different from Ballerina? Personally, I'm not expert in Ballerina, but my first impression is that it's very HTTP focused. So the HTTP is a primary kind of concept because all the world needs maybe like synchronous API. The idea here is, yes, it's written in C# because personally C# is my favorite language, I'm sorry. And I would like to make it in different languages, but there is some technical limitations at this point. C# has a concept of events, and I don't really believe that any other most popular language has events. And that kind of allows you to create like the whole holistic picture of creating the services using the command response events and queries. Honestly, I don't know exactly if Ballerina tries to tackle, let's say, asynchronous APIs like message passing, like event streaming, or does it try to do anything with the consistency problems? Personally, I'm not aware of that.
Do all that stuff and go.
Another question.
No response.
That wasn't a question.
Do you always, the way you said you can implement this Outbox, do you always do it by persisting? Like, do you offer the ability to mix and match the consistency semantics? I'll give you an example. Maybe you want to do exactly once delivery message, but maybe you don't. Maybe you could do just like, maybe at least once or at most once. So you want to say you want to write the message into Kafka or something.
Yeah.
Instead of saving it to the database or on, in addition to saving it into the database. How can people control that kind of stuff?
Okay, so the question is, how do you actually guarantee the change the, let's say, consistency settings, even if it's possible. And the idea is, if you ever use anti-framework, the idea is you create like sort of like a model which tells how your model behaves. And the similar idea with the DaSync. With DaSync, you can configure your kind of communication model saying like, hey, this service by default maybe uses HTTP, or maybe it uses something like a messaging or in combination with the event stream mechanisms. You can even, the idea that you can even configure this for a single method, it's not for the entire service. Because you need to collect some data, analyze some maybe like bottlenecks, design decisions, and you can tweak at the method level versus like the entire application without changing the code. And yeah, so you can guarantee, you can mix and match the technology, say like, hey, you know what, I don't want this method to be 100% consistent. I want to be like as simple as possible because latency makes the most of sense in this case.
So you'll have some attributes on the method, and that's how you choose?
Currently doesn't have any attributes, but it has like a side model that you can configure methods saying like, hey, this method has to be configured like this. Okay, so if we don't have any questions, thank you for participating, and you're welcome to join at the beer hall.
Yeah.
Whatever that is.
So where do we want to go? Do we want to go make minimums, or do we just want to go upstairs? Upstairs is closer.
Subtle expression of opinion.
Upstairs. Upstairs? That's one for upstairs. Two.
That Cajun talks.
I think you lost.
I think the right question is, who wants to go home? Thank you, guys.